Bem-vindos to one more episode of the Type Theory for All podcast. As always, this is your host, Pedro Abreu, and today is my great pleasure to talk with Mike Sperber. Mike is the CEO of Active Group, a company designed for counseling, development, and training in functional programming. He is a co-organizer of BobKonf and FunArch, and co-founder of the leading German blog on functional programming, functionality/programmierung.de. Don't rely on my very broken German. All the links that I mentioned here will be in the in the description of the episode. Mike is also a member of the Editorial Board of the JFP, the Journal of Functional Programming. He has been part of the R6RS, the sixth revised report on the Algorithmic Language Scheme. During this conversation, we talk about C, Lisp, Emacs Lisp, Scheme, and his involvement with the R6RS. We talk about his views on mathematics and formal methods as languages, his views on the use of functional programming in the industry, his thoughts of how object-oriented programming is dead. We talk about macros, hygiene macros, and so much more. I should also mention that in this conversation, we talk about BobKonf and FunArch as amazing conferences on functional programming and their design and architecture. So BobKonf currently has an open call for talks and goes until November 17th. Go to bobkonf.de, that's bobkonf with a k.de. Or take a look on the description of the episode and you'll find the link over there. Before we get into our conversation now, a few very quick messages so that we don't interrupt the show any further. So first, a big thank you for all of our patrons through these years of the podcast. As my way to show the appreciation of each and every one of you, I've decided that I'll start recording some exclusive content that, I don't feel super comfortable releasing out in this wild west of the internet. The internet can be tough, and there are things that I want to say only for a more curated set of people. And I believe that patrons will already understand the message that I'm trying to achieve here with this podcast. This week, I've launched an exclusive video covering at depth my participation at a conference of formal methods and computer assistant mathematics called KICAM, which is co-located with LSFA, so I've participated both. And in this video, I've covered the trends in the field, the presentations, the people, and I talk from a much more vulnerable and honest point of view. I give some of my thoughts, the people that I met, some of cool conversations that I've had. So if you'll be interested in this kind of content and much more to come, go to our website, typetheoryforall.com/Patreon. But if you don't care about exclusive content at all and you only want to support the show a little bit, we also accept tips in our Ko-Fi platform. Just go to our website, typetheoryforall.com. Any support will be greatly appreciated. Another form to support the show is to also buy some merch. Right now, I'm also wearing an amazing, really cool t-shirt, which I personally love. I use it all the time. Go to typetheoryforall.com and you'll find all the links over there. Another way that I am trying to fund myself, to allow me to produce more of this kind of content, is that I've launched a grad school mentorship program, which is currently going full steam because, the grad school applications in the US particularly goes until mid-December. So I've been working really hard with a few students to find the best labs that suits their interests in programming languages, formal methods, or computer science a little bit more at large, which, these places will allow them to thrive both academically, professionally, and also in the mental health side, which is extremely important to me. So if you think that's something you'd be interested in, go to typetheoryforall.com/mentorship and schedule your free initial meeting right now. And without further ado, let's get into this episode. Welcome everyone to one more episode of the Type Theory for All podcast. As always, it's my pleasure to be here, Pedro Abreu. And today, let's see if I can pronounce a little bit of German today with Mike Sperber. I get that slightly correct.
Yeah, pleasure to be here as well. Name is good enough, certainly.
Awesome. Mike, I'm very curious because you have quite a trajectory, like getting out of academia and being in industry, but, right kind of like in the middle. Can you tell us a little more about your trajectory, your time in academia, and what's your motivation to be, like opening companies and making conferences, that kind of stuff. Like, tell us a little bit about yourself, please.
Okay, so where do I start? I mean, of course, the trajectory, the length of the trajectory is related to my age. So I got into computing in 1983 when my parents bought me my first computer, which still runs to this day. And then I got, I kind of learned to program by myself. Fast forward a little bit, I took part in, so there's a student competition on computer science in Germany that happens every year, sort of a national competition. And I took part in that, I think when I was 15, so it must have been around 1986. There I got to the final round, and there were about 30 people in the final round, and a lot of them subsequently became my friends. And 10 of us wrote a book together, and those were the people where I kind of got out of the shell of the basement in our home, where I learned to program by myself, and I saw how other people programmed. And there were a couple of people there, notably my friend to this day, Sebastian Egner, who introduced me to Lisp-like languages and gave me a copy, or pointed me at a copy of the Purple, the Wizard book on structure and interpretation of computer programs, which is sort of the, I noticed I host a Haskell interlude podcast. A lot of people that's their introduction to functional programming. And so it was that for me as well. And while that book is from academia, it contains a lot of examples which at least try to be practical. So I always saw that not as an academic book, but as a book with, ideas and instructions on how to write and structure practical programs. And also working on that book on computer graphics with those 9 other people from that competition also got me interested in how to structure programs. Now that for the first time I was looking at other people's code.
What language was this you initially coded in?
So the book on computer graphics was written in, so the code there is written in C. We actually debated back at the time. So back in the day, we debated doing that in Smalltalk, but in the not the early 80s, but the late 80s, C was basically one of the few sort of workable programming languages on the computers.
So that was your first contact to programming with C?
Oh, no. It was much earlier. So in 83, C was had not arrived sort of on the wide market, at least not that was accessible to teenagers. And so my Apple II had AppleSoft Basic installed on it. And I kind of learning how to program for me was hanging out in department stores a lot, where they had set up computers for people to try out. So back then there was this whole variety of this whole spectrum of home computers. And so I learned programming in BASIC on those machines. And so C was something that I think ultimately I ended up learning not for that book, but I learned it just prior to starting the work on that book. And it felt very advanced at the time. I remember getting my first C compiler. It took 4 or 5 floppy disks on my Apple II that you had to switch around in order to compile the program. So finally, in the sort of late 80s, early 90s, C compilers were kind of usable in the sense that you could, just write programs and compile them. Just before that, I remember programming a lot. I'd always have a book to read because programming the things I was working on would take like 10 minutes compiling a single file. So, so type a little bit and then take a break. But ultimately, I kind of got hooked on the ideas of structure and interpretation of computer programs, and on Scheme. I didn't really think about functional programming, or think of it much as functional programming, because it also lays out a path to object-oriented programming, for example, that book. And so eventually we finished writing that book in C. I graduated. I started majoring in computer science, and remember meeting one of the research assistants at the university back then, Gerhard Koschowek, who was he had a Miranda system set up on one of the university computers, and I think also a standard ML system that he showed to me. And that really, I thought, was super cool. And he referred me eventually, when I moved from there to the University of Tübingen, to Peter Thiemann, who's my friend to this day. He's a professor of computer science in Freiburg now, but back then, I mean, we ended up sharing an office at the University of Tübingen doing research on functional programming. But even then, I always felt that the research we were doing should feed into practical programming at some point, right? And I felt that especially the scheme systems that were available at the time were eminently practical. I worked for a while with Olin Shivers and a couple of folks at the University of Tübingen, my coworker Martin Gasbichler, for example, on Skish, the scheme shell, which is eminently applied functional programming, still unsurpassed to this day, I would say, in what it enables you to do. Yeah, and so that was always on my mind. So my PhD was, I guess nowadays you would say it was on software architecture. So I was interested in theater at the time. So my PhD thesis was on developing a system for stage lighting control. So that was also a practical system. It sort of didn't seem very special to me at the time, but I kind of realized it was one of the few sort of pieces of one of the few end user systems that were implemented using functional programming. And so that was always on my mind, right? I kind of got fed up with sort of the research culture in Germany, and so I kind of had to leave for my own sake, and I really wanted to get a more applied vision of and applied idea of how software development in the wild happens. So I left the University of Tübingen, I think in 2003, and was a freelance software developer for a while. Got in contact with a lot of projects, and then in 2010 joined the company that I'm still with to this day, with Active Group, which is a software consultancy. And back then it was kind of a run-of-the-mill consultancy, but we've transformed it since then into one that specializes on functional programming and functional software architecture. So I'm seeing if all those funky ideas that we had from functional programming, all those ICFP papers, all those things that I'd encountered over the years, if they would actually pass the test of being applicable and useful in practice. And it's panned out pretty well, I would say.
Out of curiosity, what kind of conferences did you aim in your PhD? Because it seems like you said that it's lighting control for theaters. Like, what kind of community were you in?
Well, I was mostly in the sort of local student theater community at the university. So there is actually a small German sort of stage lighting system community that I was in at the time. But I was kind of at the fringes because when people were thinking of lighting systems back then, you can go backstage at any big theater. You'll usually find a window in the back, and if you look there, you'll find like a giant console with lots of levers and dials and things like that. And I always felt that was that communicated a very technical vision of lighting, right? You would have, you would turn a dial and a specific light would go on. Of course, if you are directing theater, then you have an artistic vision where you don't think of individual lights. And so I always felt that was a poor match. And so I came up with, functional ideas of how to model stage lighting. So that was mostly driven sort of from a computing perspective and from my perspective as somebody who's involved in sort of the artistic side of theater. In the practice of theater, or the artistic side and sort of the lighting side are kind of separate things. So it was that turned out to be sort of difficult to bridge in a commercial sense. But the system that we developed was eminently useful, and we still use it to this day, even though I think the last version I put out was over 25 years ago.
Wow. So it's good software.
It's still a good piece of software. Yeah.
Good.
So
Nice.
certain things have happened, but that it hasn't quite adapted to. But I mean, all the rise of LED lighting and RGB lighting and cheaply available moving lights and things like that. But for sort of solid theater lighting, still a very usable and efficient system.
You also mentioned that you were unsatisfied about academia in Germany. Could you tell us a little more about that? Because, today academia can be pretty rough and toxic in many ways. Like, was it already like that back then?
No, I wouldn't say it was toxic in the sense, right? And in the one sense, German academic system offers a great deal of freedom, or offered back in the day, offered a great deal of freedom. And so Peter Thiemann and I, as we shared an office, right, we would show up to work and we would think about, what are we going to do today? What are the problems that we want to work on? And nobody would get in our way, right? And I think in Germany, though, again, back in the day, the publication pressure wasn't all that great. I mean, we did, I think, given what we're doing quite well on sort of the publication front. But of course, a university has two missions, right? One is research, and the other one is teaching. So I was very interested. So I kind of, maybe again, sort of moving back in time a little bit, I got interested in teaching how to program really early as well. So the first sort of proper computer science class that I taught was when I was an exchange student in the US in 1987. And there they let me teach an AP computer science class.
Cool. Where was it?
In Honolulu, Hawaii.
Oh,
so
cool.
It was very nice.
Wow.
In more ways than one, but it was also very. For me, it was a great school environment as well, because again, there were lots of sort of like-minded people, and I had all the freedom I needed to pursue the things that I was interested in. So I was really interested in teaching. So both of my parents were school teachers, so it kind of runs in the family. And so the what kind of happens at German university, or again, back in the day, maybe things have changed a little bit. There's the German constitution says that, research and teaching is free from, of course, political interference. That's a good thing. From the student's perspective, it would be nice if there were like an organized curriculum where the pieces would fit together and that would give you some coherent picture of doing things. But of course, if every lecturer and teacher and professor, is free to do their own thing, then it kind of depends on people agreeing to work together to create something that works well for the students. And that agreement never existed. So, for quite a while, I worked on the intro class, the introductory course in programming. And I kind of work on that to this day, because what we did back then is eminently relevant for teaching in the commercial space that we do these days. We didn't just teach the class, but did some research on how well we were doing and published on the results. We wrote a succession of books on how to do this. We made sure that other people were also able to teach this class without, having to rely on our enthusiasm and specialized knowledge and things like that. And so we built on the knowledge of others. So that's what often does not happen in teaching. Everybody kind of teaches their favorite thing, but it's sufficiently difficult that it's really useful to be able to rely on others' experience and their reports of it. But it kind of happened in a vacuum, right? We were, we constantly had to kind of fight for what we were doing. There's the usual discussions, why are you doing this using this arcane discipline of functional programming? Why are you not doing it in Java or C++ or whatever everybody else is using? The usual discussions that I think everybody had at the time that was teaching. But fundamentally, there was no agreement in this faculty to provide a good learning experience for the students. So, that just got to me more and more as the years passed. So, and I was able to sort of improve things in my own little corner of what I was doing, but it really, I think, would have been necessary to work together on something that's slightly larger than just a single semester or a succession of 2 semesters in order to provide that good experience. And that agreement was not there. And I mean, one thing that I think I only found out later, but I really like working with other people. I mean, I started out in the basement all by myself. And for the longest time, I'm an introvert, so so working with other people for me is exhausting sometimes. But it's also something I really enjoy. And I learned that for the first time getting together with these people that I mentioned from that national competition on computer science. But I think it was not until my 30s that I realized kind of what that meant for me. I really needed to work with people rather than sort of alongside other people, and trying to build something together. And that was just not possible at the university. And so first of all, I had to leave, and then gradually I kind of, from there, had to build up something that was, that suited me better, I guess.
Is that how you ended up at Active Group?
Yes. I mean, again, maybe not immediately, but I remember, so at the time I was a freelance software developer, but I was also looking at job adverts. And as you can imagine, there are very few, especially in Germany, there were very few job adverts that suited my background.
Which year is this? Give me a picture of what was going on in the world.
We're talking about 2010. So I've been doing consulting, freelance consulting for 6-7 years. And mainly I was working on software projects. I occasionally would get to use, functional programming. I'd still, at the time I was working on the Scheme programming language standard. So I was still keeping a profile there. I was working on Scheme language standardization during that time. And sometimes I was able to apply functional programming in the projects that I was doing, but they were not originally billed as being related to functional programming. And then there was a job advert that mentioned functional programming. I think it even mentioned Haskell and mentioned logic programming. So since I was always considered myself a programming language person, thought that's rare. And then I kind of looked at the map of where that was in Germany, and that was a half-hour's drive from where I was. So that was even more surprising. So this was actually a job advert by Active Group that were looking for somebody to be sort of the German representative for an American client that had their own programming language, run by Frank McCabe, who was one of the original Prolog people, programming language, wonderful programming language designer. But as I was kind of alone where I was, he was kind of alone within his company working on that programming language. And so I think he felt fortunate that there was somebody else who understood what he was talking about and what he was trying to do. But I remember in the job interview, actually, my later boss, asked me, "Do you like?" I was like, I mentioned that so that working with other people, I'm sometimes not very good at making compromises. Let's put it like that, right? Which is why I left the university. I'd sometimes just not taken on projects or left projects as a freelancer where I felt the technical vision was too far away from where I felt it needed to be. And so I mentioned that and said, well, just so you know, right, I'm not here to just do anything as long as it brings in the money. But constitutionally, I need a certain I need a certain proximity to the contents of the project that I'm working on. And then he said, "Well, do you like working with other people?" And I remember having to pause. But that was the first time that I thought about this. Right? Is it? And I think that might have been sort of the beginning, or of a conscious thought process of what I wanted to do, not just on the technical and technological side, but also on the human side of computing. And so that eventually led me to, I ended up taking on this job, working with other people. I ended up creating a bunch more jobs. And then I ended up being CEO of that company, which I still am to this day. And while the company works on functional programming, I think I spend most of my time on trying to have us all that were in this company build something together. And I enjoy that.
That is so interesting. So that's when you started realizing that, well, not like you mentioned a couple of times how you like to like, you realize that you like to work with other people, but at the same time, you're also kind of like thinking in a more institutional level, right? Like more, what are the real problems that we're seeing in institutional level, right? And it sometimes starts like deviating things from the actual coding, and it can be a little frustrating depending on your background. Like I wanna like, you have to kind of like start making decisions of like, do I want to be coding and making the product, or do I want to be, like, deal with people and institution and bureaucracy as well? How?
Yes. I mean, I guess I learned that, right, being here and as a freelancer. I think that's not news to sort of people outside the functional community. I think it's I think it's kind of telling, right, that if you talk to functional programmers, they want to talk about the sort of technical side of their code. Um, but and that's fine for sort of research papers and like the 5-line or maybe 20-line pieces of code that you find in research papers. Um, but of course, I'm interested in writing systems that grow significantly larger and more people, more than one person gets involved. So you need to think about the human side and how to organize the human side of that. And the software architecture community is very aware of that. I say so, and for them, I think most of the work that they do or that they consider themselves doing is sort of more on the human side of things. So I remember a friend of mine did a survey at a developer conference the other day and said, asked what is the most important skill in IT? But he was mostly asking software architects, right? And everybody said communication, right? I think that's a little boring. I mean, because as you deal with larger groups of people, it's, of course, communication is going to be extremely important. So it's kind of I feel like that kind of doesn't need saying. So try to say something more interesting at the time. But so the software communities at large, I mean, the software architecture community, also the object-oriented programming community, they're very aware and they've been thinking for a long time on how to bring together the technical side with the human side of things. And we haven't done that. When I say we, I usually mean like the functional programming community. And we've done that at a local level. Lots of people have been part of teams that successfully did functional programming projects and larger software projects using functional programming. But how the human side of things and the technical side of things, how these things play together, and what might be specifically functional about that is woefully underdocumented and undercommunicated. So there you go. So I mean, I guess that's what I learned over the last, 15, 20 years is really that we need to carry. So if we really think that whatever it is that we do on the technical side is important and more people should be doing it, functional programming in my case, and somebody else might say formal methods and somebody else might be saying something else. Eventually we need to think about that together with the human side. And there's lots of connections, eventually, why are type systems a good idea, right? Or why is the lambda calculus a good idea, right? On the face of it, doesn't really make sense since these are sort of mathematical ideas. Why would they apply in the world at large? Why would you design a programming language from an arcane logical calculus rather than from practical requirements, right? And these things have to do with the human side of computing, not because mathematics fell to us from the heavens, but we tend to pretend that in functional programming that it did fall from the heavens, specifically with type systems. So that's what I find interesting these days, right? Is to consider these things in tandem. And try to make them work well together. And that requires, of course, interacting with other folks. So the politics, of course, you mentioned the politics of it. Of course, eventually get to the politics of things. But I've just gotten to a better place than I was back in my university days, I guess. I mean, I've got lots of great people around me, an active group, and active group in some ways is also a political project. I take part in some other institutions where there's also political activities. But I'm able to have more impact there. Let's put it like that, and having more productive conversations, even with people who have very different opinions from my own.
You mentioned that the use of all these arcane ideas from mathematics that leads to functional programming and the calculus has something on the humane aspect of it, on why it's good to use these things. Can you tell me a little more about that? What do you mean?
It might just sound a little bit esoteric, right? But let's maybe just consider mathematics in general, right? I mean, the lambda calculus type systems are generally represent a mathematical way to think about programming, right? And one thing to consider is, I mean, there's this famous Galilei quote, I think from whatever, the 17th century, where he said, well, mathematics is the language that we use to describe nature, the world around us. So, I mean, one way to think about mathematics is it is the way that nature works, but I think but really, I think it is more a tool that enables human brains to think about nature and to represent nature. And it is shaped as much by sort of the physical structure of the nature or the world around us as it is by the structure of our brain, right? And we know that our brain is predisposed towards certain patterns. Otherwise, we wouldn't have music, things like symmetries and things like that. And I think that there's sort of an abstract basis there that then leads to mathematical structure, right? And the structures that we use in programming might be things like, I mean, starting with things like maybe monoids or semigroups and things like that. Now, why would a semigroup, like an abstract algebraic concept, be helpful in structuring software that is about the real world? Which it is, right? And that's because it kind of represents, to my mind, it represents sort of a distilled brain pattern, right? It's something that the brain likes to use to think about stuff, right? And therefore, it's something that our brain tends to like to apply to other real-world domains as well. So, of course, semigroup is an abstract word, right? But third graders know the concept of associativity, even if they don't know the name for associativity, but they understand that concept, and that's when it's being taught, at least here in Germany. So, so the things that tend to be useful in programming from mathematics, things like some algebraic concepts, right? They are, in my mind, they're primarily brain patterns. And so it's what the brain likes to use to think about things and to structure and to order things. And now in practical software development, I mean, there's a large community that says you should just, as a software person, you should just shut up and listen to the domain experts and implement what they say. So, but I think that falls short because you forget that there's a human in the loop, right? When we implement a software system, we don't implement a model of reality. That goes a straight line from reality. Instead, what we do is we implement somebody's understanding of reality, right? And so it goes through a human brain that has structured this problem in a certain way. So not in an arbitrary way, but in a certain way that sort of goes well with the human brain. So there we go. So there's mathematics, why that should be relevant. I mean, humanity has developed that for hundreds of years. And so that's why something like the lambda calculus, which was developed before computers existed, right? So the lambda calculus is something that seems to go well with the human brain when thinking about names, right? Humans like to name things and deal with names. And I mean, that was, I think, one of the primary motivations of using the lambda calculus to then as a basis for the Lisp programming language. And so this is why taking things from mathematics, even though it doesn't have anything to do with the immediate requirements of programming, right? I mean, we could think of it from the other side, right? We're trying to implement some super concrete, messy domain. We're trying to implement whatever, the self-driving car or the whatever. I mean, we work a lot in factory automation, so we think a lot about controlling machines. A lot of my friends work in e-commerce, so they want to implement e-commerce sites. And of course, the domains there are messy. So you could think about, well, coming from that domain, how do I then go to a computer implementation, right? And that would arguably not lead you. You might not encounter mathematics on the way to that from there to sort of machine code. So why is it that the mathematics is so useful? Because it's common to all of our brains, right? It's common to our brain structure, and that's why using solid mathematics to do programming language design and things like type system design and so on, even though mostly it was written. All of these things were designed completely ignorant of concrete requirements, tend to be useful in implementing requirements. I think that's fantastic. But of course, this also represents an extreme picture, right? If you look at type systems, lots of type system papers, in the aughts and in the 90s, definitely, they were written. A lot of that design happened completely in a vacuum, right? There were very few times you would see papers where actual requirements of writing large-scale systems or modeling concrete domains would feed into doing that, right? The arguments for changing or adding something to the type system would mostly be formal. Still, useful stuff came out of it, but occasionally it does help to think about requirements when you're thinking of putting a certain feature in a type system or not, right? Or to think about, how can we actually support actual real world projects with the designs that we're making? That makes any sense?
It does. I definitely like that idea that the domain is being kind of filtered through the human mind, and that's all about mathematics and how to connect those patterns and those structures. But you also mentioned that, so when you got to Active Group, you already they wanted to do something with Haskell, and you were already involved with the Scheme community, Lisp community. How was your involvement back then already? Like, how did you get to functional programming?
Well, so I mentioned the Purple book, or the Wizard book, Structure and Interpretation of Computer Programs, and that of course uses Scheme. And it's like, if you like that book, you tend to like Scheme coming out of it as well. And then I happened, actually, second university I studied at University of Hanover also used Scheme in the introductory course, so it was nice to be able to explain to use what I already knew and not have to study so much for class. And so I just enjoyed hacking in Scheme back in the day. And I remember so the Scheme standard comes out in revisions that are numbered. So right now this was the early 90s, I think the third version of the standard had just come out. It was the main one that was in existence. The fourth version just came out. And there were these, the early version of the Scheme standard were these really short documents that were like 50 pages, and that were eminently readable. So, even as a beginning university student, I was able to read those documents and get an idea of what that programming language was. So maybe not quite a childhood dream, but I thought, these people that are doing these reports, they know something that I don't. It'd be really cool to understand what it is that they're doing. And so I played some more with Scheme, and eventually settled. With Scheme, there's lots of implementations of Scheme, right? It's both the blessing and the curse of the Scheme programming language, that there isn't just a single compiler or a single implementation, but there's more than a dozen, and it's maybe foolishly easy to implement a new one. And so new Scheme implementations come out even today. And I remember stumbling upon one called Scheme 48 that I really liked. It felt really ergonomic to it, and I was able to understand how it was structured. So the 48 in the name is you're supposed to get the impression that it was written in 48 hours, which is not quite true, but you kind of can get a fairly good idea of its architecture within 48 hours. And a lot of the ideas on how to implement real-world systems using functional programming came from studying the Scheme 48 system. So I got in touch with the authors, with Jonathan Rees at the time and Richard Kelsey, and kind of kept in contact with them. And I mean, the beauty, the architectural beauty of Scheme 48 is that it's fairly easy to change. You can do your own things with it, right? And so I got to the point where I submitted some patches to fix problems or make some enhancements to Scheme 48. And then I also got involved in the Skish project that I mentioned earlier, the scheme. So it's a Unix shell DSL built on top of Scheme 48. So I'm now at the university. I'm publishing papers on doing stuff with Scheme 48. And I ended up being maintainer of that system. So that was how I got involved in Scheme, first of all. And so I had papers at the Scheme workshop. And eventually at a Scheme workshop, there was a meeting to present the 5th version of the Scheme standard. So I mentioned the 4th version came out when I was at the university, and then it took a couple of years. The 5th version came out. And that was done by Richard Kelsey, who was also one of the authors of Scheme 48. So I was pretty close to, I think I spent a summer at NECI where Richard worked as he was finalizing what's called R5RS, the 5th edition of the Scheme standard. So I was at that meeting, people thought, well, it's cool that it's finally come out, Scheme, the 5th edition of the standard. People felt that it had taken a long time. And also Scheme standards up to that point, changes to the Scheme standard had to be decided by unanimous consent of the committee at committee meetings. And so that prevented certain very fundamental ideas of getting into the Scheme standard. Things like compound data types, like records, for example, weren't in the Scheme standard for the longest time. Not because somebody thought it was a bad idea to have it, but because people couldn't agree on which design to adopt. And so at that meeting, people felt that going forward, if Scheme was going to continue to have impact, it had had enormous impact up to that point, then probably the mode of standardization would have to change. And so eventually I ended up on the committee that did R6RS, and near the end of that process, I became project editor of the R6RS standard, which came out in 2007. So by that time, I'd already left the university for a couple of years and had been doing that on my own time. So that's sort of the Scheme side of things. I mentioned that at the University of Tübingen, I was working with Peter Thiemann, and Peter Thiemann was very much into strongly typed functional programming. And so he taught using the Hope functional language, one that's kind of underappreciated, one of the foundational functional languages. And then, this is the early 90s, and then Haskell came out, and so he wanted to play with Haskell. And so we did a bunch of stuff with Haskell as well. So through Peter, and also, previously at the previous university, I'd seen StandardML and Miranda, also strongly typed languages. So this kind of expanded my horizon, not just to sort of Scheme and Lisp-like languages, but also to functional programming in general. But I always had this sort of two-track thing going of being sort of with one foot in the untyped world of Scheme and the strongly typed world of the StandardML type languages, such as Haskell. And we ended up publishing a couple of papers on there as well on Haskell.
I'm surprised that someone actually teached with Hope. I did have David McQueen, and one of the fathers of Hope here, and he was also talking about, like, he was developing this at Bell Labs, and that's exactly how like where people were developing C. But I was like, wait, so you guys like very close to one another, but like Hope has, like, what you guys are doing has nothing to do with C. Like, you're not talking. It's like, not really. We didn't talk that much. But anyways, very interesting to hear how you guys were using these ideas. Very, very cool. And yes, I definitely agree that Hope is highly underappreciated. Like,
I should mention, one of the things that Hope had going for it is that, if I can reach up right, is that one of the great books on functional programming uses hope, right? And that is from the mid 80s.
Cool. Wow.
So this book right there, still one of my favorite books on functional programming.
Let me see it again for the people who are listening.
By Tony Field and Peter Harrison.
There you go. Thank you.
And many years later, as I was working with Active Group on a EU grant application, I had the pleasure of sort of accidentally meeting Tony Field at Imperial. So that was a great pleasure to then say, well, okay, I remember your book, even though it was over 25 years later.
I don't know much about Lisp-like languages. I've never worked too much or looked too much into it. So what's the idea of scheme coming out of Lisp? Like, what is the kind of like the problem they're trying to solve? Like, what is the reason of being of scheme?
Well, so, I mean, when Lisp came out originally, I'll try to make this short, of course. I mean, Lisp came out in the late 50s, right? And I mean, it was ostensibly based on the lambda calculus, but there was a famous bug in the implementation, if you will, in that the early versions of Lisp, or not just the early versions, but sort of original Lisp used something called dynamic scoping. So we're used to in modern programming languages, almost exclusively, you have a principle called static scoping. So you see a variable somewhere and it's declared somewhere else, and you want to match the declarations with the uses. And it's much more ergonomic if you can do that statically by looking at the program. So if your use of a variable, you can tell, well, it's this declaration here that goes with it, right? And then dynamic scoping, this gets decided at runtime. So you don't get the statically enclosing declaration, but you get the one that was done last at runtime and that hasn't been sort of canceled yet. So eventually people discovered that you can do surprising things with that, but it's not great for software architecture because it tends to destroy local reasoning. So when the time came to sort of get more serious about Lisp standardization, one thing that happened for the major dialects of Lisp, or one was Common Lisp at the time, is that they changed to static scoping as well. So that's one thing that happened on the way from original Lisp to Scheme. Then there was another idea where, a notable difference between the lambda calculus and Common Lisp is that it's Common Lisp and all other Lisp variants at the time is that they're called Lisp 2s, and that they had separate namespaces for functions and other things. So even though, right, in functional programming, we kind of think, well, functions are things as is everything else, but in the original, in Lisp 2s, they're not quite the same thing. Separate namespaces. So in Scheme, you have one unified namespace for everything. Also, as it turned out later, for the macro system. But the foundational thing that happened for Scheme, Scheme was mainly developed originally by Jerry Sussman and Guy Steele. I forget. So there was a series of papers that I think Guy Steele was always involved as a co-author, today called Lambda the Ultimate papers, and Guy Steele discovered what today is known as the concept of tail recursion or tail calls, right? That you could transfer control from one place to another by just doing a function call. And this was new at the time, or this was a fundamental idea at the time, because sure, you could always use a function call to jump from one place to another, but this would cost you because that function call would use up a little bit of space on your stack or on your your continuation store or something like that. And this meant that you could only do so many of them because stacks were and are to this day limited in size. And so the foundational idea of Scheme was, so what Guy discovered is, well, if we could just fix that, right? So that for the calls that don't require it, they don't allocate space. And this way you can do infinitely many of them. This really was the key to making function calls the fundamental, not just the fundamental control structure in functional programming, right? Previously, you needed to have separate constructs for things like loops. Lisps have generally specialized loop constructs, and you need them because you just, that recursive way of writing functions only works if it only works in practice if it doesn't crash because of a stack overflow. So Yeah. So I guess so scheme, and there were debates after that over time. But the foundational idea is tail calls, I would say. And then there's a couple of other things that kind of, the early Lisp had a concept called nil, so the sort of the empty list would also count as false, and that got changed in Scheme. So just Scheme was kind of regularized version of Lisp, but the real reason for its existence was tail calls.
Oh, cool. Okay. Interesting. And how was the committee, like how is the committee organized? You said that there's a committee that has to vote for the next standard. Who is this committee? How do they get there?
Yeah, good question. So, up to version 5 of the standard, there were just physical meetings, and the committee was constituted just of people who showed up at the meetings.
Cool.
And so, that meant it was kind of American-centric, but it worked, right,
Okay.
until revision 5 of the standard. And then there was, after version 5, and I was involved in the 6th revision of the standard, there was kind of a slightly chaotic process, I would think, where there was a scheme workshop and people talked about who might be on the committee. And then a certain set of people got chosen. But there wasn't, this organized process that you would expect from an official ANSI or ISO standardization process, because I think as a community, we just didn't know what we were doing. Slightly later in the process, we kind of thought, well, if there's significant conflict within the group of what was called the editors of R6RS, it'd be great to have a body that would be able to resolve those disputes. And then we decided to have a steering committee, and the steering committee would then institute procedures to keep the whole thing going. But one of the problems, if you read up on R6RS, I think the end product was pretty good. I have to say that kind of as project editor, but I actually think it's pretty good and it's held up pretty well. But the social aspects of the whole thing, the human aspects, were there again, weren't managed very, very well. And the I'll spare you the gory details, but maybe one of the things is that, right, so a scheme, right, given that it was this really, it was this example for many years of this beautiful language report, right? It was just 50 pages. You could really just read it. You wouldn't have to decipher the symbols to figure out what it meant or whatever. You just read it and you could understand it. And it had this famous foreword where it says, programming languages should not be designed by piling features upon features, but instead by removing the obstacles that prevent the existing features from being combined. I think that's almost verbatim it, right? And it sounds so beautiful, right? And it gives you this impression that Scheme is this programming language where things are being done right, in the right way. And this is not just, it's not just true to the Scheme community. I think in a lot of other functional programming communities, sub-communities, there's also this idea that there's one way to do things right. And the Scheme people thought, well, the right way of doing things is represent, and everything where it's not clear what's right, such as the records, right, we're just not in the report. So I think that's kind of the attitude with which a lot of people, including myself, approached this report, that we were going to do things right. But there's two problems. Of course, there's trade-offs, right? Something that's right for one purpose might not be so great for another purpose. And then there's also this problem in that this famous opening remark that I just quoted on whatever, don't pile feature upon feature. It means whatever you want it to mean. And it took me a long time to figure that one out. My biggest regret is not taking that out of the report. So if I think over time, the R6RS committee realized that we were going to make compromises and that we're going to have votes, and that we should, and we tried, as time passed, we tried to get more and more transparent about how we made decisions that were there. But I think a lot of people still read the report with this idea of, well, it has to be all the right thing. Everything that's in the report has to be the right thing. And as soon as somebody thought, well, it's not my idea of the right thing, they would go, it's, a pile of poop, the whole thing. And so there was very little sort of middle ground where we'd say, well, maybe we could accept this thing for what it is right now and then improve it, right? I mean, R6RS represented a big leap in that it was structured differently from R5RS, and it was the first version that had an explicit list of requirements in the beginning geared towards actual real-world programs. Whereas the previous versions were mainly there to enable code and research papers to be read by other people. So, and it didn't really have explicitly formulated requirements. So this was the first version that had that, and that was really geared towards real world programs. And so, as anybody knows, outside of the functional programming community, real world programs get done by iteration. You iterate, all right? You write something, you put it out there, you collect data from actual usage, you see how it fares in the real world, and then you improve upon it. It doesn't by deciding the real thing, throwing it over the fence, and then working on the next That's not how software works. And this is also how how programming language standardization should be approached. And most communities understood that, but the scheme community, the scheme community, I'm as guilty of that as anybody else, certainly didn't understand it.
Who are the kind of stakeholders in this committee? Like, what are their interests here?
Yeah, well, that's another. I mentioned that scheme community really is unique in the sense that there's lots of people, lots of implementations, and that means lots of implementers, right? And so I forget how many, but there were several implementers involved in the committee. And of course, I was one as well, and Richard Kelsey was there at least for a while. Well, you can read up. There were a bunch of implementers, right? And so one of the problems was that the requirements that we formulated were all user-facing, right? So they were like, you should be able to do this with the programming language, whereas the people on the committee were implementers, and so they have different interests from the users, right? Prominently, there's two places where that plays out. One of them is the tail calls that I mentioned, which were from the standpoint of certain implementers. So there's implementations of Scheme that compile to C, for example. C doesn't have proper tail calls. And so it's very difficult. It's basically impossible to have a Scheme implementation that compiles to C and that has good interoperability with C code. It's possible, but it's difficult to do efficiently. And so there were implementers who said, well, I really want us to take out the tail calls from the report, right? Which then would require certain other changes in the language so that people could still write iterative processes in the language. And so that's where, that's one implementer influence, which was certainly legitimate, but which ended up not being in the report. The other one is that what Scheme really has, far beyond every other programming language on the planet, is its macro system. And that so the uniform syntax that Lisp has. So Scheme is I didn't really mention the syntax aspects of Scheme, but Scheme has a Lisp-like very uniform syntax, very different from most other programming languages, instantly recognizable because of all those parentheses. And this enables, because everything is very uniform, enables you to implement a system that enables you that allows programmers to add things that look just like the built-in things to the language at the syntactic level via its macro system. And if you ever use macros in a programming language, you realize it's a cool thing, but beyond a certain level of complexity, it's impossible to get these things be done robustly, mainly because of variables, right? I mentioned that Scheme and the Lisps, and the defining thing was this lexical scoping, and that you can determine the binding site or the declaration of a variable from where the occurrence is. And you lose track if your macros are usually a textual replacement mechanism, right? Popularized, I guess, with in my trajectory in the C language, right? There's a C preprocessor which knows nothing about the binding structure of the program, which just does a textual replacement, right? And if the macro mentions a variable and gets expanded in place A and in place B, it might refer to different declarations, right? Because there's some capture goal, because you just put it in the scope of some declaration A, and then you put it in another scope, and because it's just purely textual, you just write it's called A, it refers to different bindings. That makes sense. So with macros, as they reach a certain level of complexity, you lose track of that, and then it just becomes impossible to maintain. Right? And if you look at old C code, I don't know if they still do this, but the C code that I was involved with, right? Macros were also constrained. They could only be do on one line, but you could continue the line by putting backslashes at the end, and it would just, at a certain level, you would just stop doing it. Even though you could do some amazing things with it. But of course, it's really useful. I mean, as your macros get sort of more powerful, you segue into not just sort of library design or feature design, but into language design, right? And this is great because some, problems in software engineering can very well be solved by doing what we now call the domain-specific language. And for doing that, you need more powerful macros, and specifically, you need to address this problem of variable capture. And so the Scheme community came up with this idea of hygiene, hygienic macros that would preserve this lexical static binding that I was just describing. And that was like the main power tool that would enable to have much more expressive macros, and therefore you would really definitely be able to cross the line into domain-specific languages. Now, I'm sorry, what you originally asked is, well, the committee, how did that play out? Now, it turns out that these hygienic macro systems, they are a pleasure to use, right? It's like Christmas every day. But they are hard to implement. They're really difficult to implement, right? And I mean, as the years pass, we're learning sort of more succinct and elegant ways of describing the semantics of the macro. But back in the day, as we were doing R6RS, it really was pretty complicated to describe the implementation and also the specification that was in R6RS. And so certainly some implementers were just fighting against having to implement all the complexity of the macro system. Of course, the macro system plays into the module system, so all of these things played out there. So in that way, the R6RS committee was unique, I think, in that there were basically mostly implementers, and there was very little user representation in the committee, and so we were ill-equipped to resolve the conflicts and the trade-offs that emerged from this. I think we still did pretty well in the end, regarding the social difficulties of this. But it was certainly always a factor in the discussions.
Sounds like a lot of work to, organize all of these different human aspects and getting all the people on the same page.
It was a great educational experience. So I learned tremendously from that, and I, especially from some of my fellow committee members. Looking back, it still feels I was very young and inexperienced with this kind of work.
Right.
So a lot of other people on the committee were doing better than I was. So I'm very happy that I went through that experience. But while it was going on, it was very painful at times.
Out of curiosity, what does R6RS stands for?
So it's first of all, the first thing was called the Report on the Algorithmic Language Scheme. So, and then it was and then came out the revised report, and then came out the revised report.
I see.
So it's revised to the power of 6. So it's the 6th revision. Right, you get the idea.
Gotcha. Okay, so this is more or less how you ended up being involved in the functional programming side of things. You're always interested in the aspects of teaching, and you get into active group as well. And so what was the work at active group you were in before getting grinding the career ladder up until CEO?
Well, it was one step. It was 2 steps, I guess, from where I started. So originally, I was just sort of a software developer that was assigned to this client in the U.S. Starview sadly no longer exists. And what they were doing is they were getting into sort of event processing systems. So they came out of the semiconductor industry, where semiconductor production is very complicated and lots of things happen. So you need a lot of monitoring and event processing, which is something that we do to this day, that we're heavily engaged in. And so they were trying to do a platform that would generalize that was trying to generalize their experience from the semiconductor industry to other industries. And so they built up what they called the platform. And that platform, the idea was that, well, you would have some sort of system where you could graphically hook it up to sources of events and then do some processing by graphically arranging sort of a pipeline. And of course, that's very consonant with just having a composition of functions. And so they ended up hiring my friend Frank McCabe, who was a programming language, who is to this day is a programming language designer, and had been involved in Prolog, but has also designed languages since then. And Frank, even though he'd come from logic programming, decided that the right way to do this was to have a functional programming language. He read up on so he educated himself on Haskell specifically. So the programming language that he designed is called Star. You can still find somewhere. And Star was heavily influenced by Haskell, in the sense that it had a Haskell-like Hindley-Milner type system, that it had, I forget what it was, if it was called type classes, but it didn't have type classes, which is something that not very many programming languages adopted from Haskell.
Is it lazy?
It had, It was not lazy because it had a compiler to the JVM, so it was a strict version of Haskell. Yeah, good point. But it was unfinished, right? And specifically, so one of the ideas worth exploring was that really resonated with me is that Frank also designed a macro system, which is, I mean, the whole idea of macro and syntax transformation is kind of a disaster in Haskell. So he did something else, which was sort of in the middle between sort of the Haskell style of doing syntax and the scheme style of doing syntax, but wasn't hygienic. So that's something that a lot of people weren't familiar with at the time. So they just, as it was unfinished, and as Frank amazingly productive, but still it was too much work for him to evolve that into a practical platform. And at the same time, they were trying to deliver stuff to the clients, and so they really needed help. And that's what they hired me for. So I ended up working with Frank on the language design, on the library design, a little bit on the language implementation. I remember, specifically on the back end, the JVM is kind of a poor target for functional languages. And we were working on serving the needs of the clients of this company, of semiconductor companies, and trying to make that fit. It was all a little bit too much for a small startup, so that thing eventually folded, but we certainly learned a lot in the process. Again.
And how do you see from that time moving to now, the interest in the industry for functional programming and your job on kind of like selling the benefits of functional programming? How are those?
Yeah, good question. So, I mean, what happened after that was, or I guess during, I mean, we realized, I need to backtrack a little bit. So Active Group had just come out of the financial crisis of 2008, right? And they had shrunk to sort of minimum size, and this was the first client to sort of get them back on track again. But there was not much left of the old business. And so it was clear that in order to hedge the risk of Starview, which was the startup, I mean, they were a great client, but it was clear that they might fold at any time, that we needed to acquire other clients. And the old business did not have enough volume to do that. And so since there was literally there was no one else, right? There was one developer left at Active Group when I joined, and he quit shortly afterwards, and moved somewhere else. And so I was the only one left. And so we consciously sat down and said, well, I'm kind of the only guy here, because the leadership of the company was that they weren't computer people originally, right? They were founders, but business people, not computer people. So if we were going to do anything, if we're going to do any business, the old business has died, so we need to establish a new one. And now here's Mike, and the only thing that he knows how to do is functional programming, but he does have some experience from his time as a freelance consultant. And so we figured we were going to try to turn that into a viable business and sort of try to get the kinds of clients that Active Group had before, and and try to apply the things that I knew, and over time expand the company. So that was one part of it. So that we consciously developed a business strategy that was really originally built around doing functional programming. And then I'd been previously at the University of Tübingen. I'd even taught there while I was still being a freelance consultant, and even a little bit of time into my stint at Active, my beginning years at Active Crew. I was still teaching at the University of Tübingen, and so I had by that time trained a lot of students. And so that was a perfect hiring ground for us. And so a lot of the people that we hired in the initial years, and that still are at Active Crew, are my former students. And so gradually we acquired clients. I mean, most clients don't have an original, I mean, they want to get a problem solved. So they don't really have an original interest in functional programming. So that was, for them, that was just a means to an end. But of course, it's a growing part of our business persona, because we need something to distinguish ourselves from other consultancies. And if functional programming is not it, then I don't know.
Do you think it's hard somehow to bring this to the client? Because one thing that immediately comes to my mind is the client will be like, well, if we take this piece of software, we're kind of like tied too much with you guys. It's going to be a little harder to find functional programmers if we don't know what is that thing about.
Well, that's technically true, but that is not unique to functional programming, right? And so we could simulate between the two of us what the arguments you might be that you're going to exchange. But ultimately, once you start getting into that kind of argument, the more typical argument is, how are we going to hire programmers off the street that can then join our project, right? And just, I'm sure everybody here listening has heard this argument, but it's a strong, it's usually not put forward in good faith, because, getting into any project really requires, any larger software project that has lived for a couple of years doesn't just require getting into the programming language that it's written in, but also requires to learn about the architecture of the system. There's onboarding involved, the build system, the CI system, the bug tracker, the issue tracker, how things are organized, how the team is organized, and so many other things that completely dominate onboarding time. So people know this, right? Sometimes people are trying to manage risk. Is that technology going to survive? But again, if you think about that a little bit, in the late 90s, early aughts, right, the safe bet would have been to bet on the world's most popular established programming language, Visual Basic 6. Microsoft just canceled it, right? And so there is no safe haven there in the space of technology, and people usually know this in their heart of hearts.
Yes.
So, what it really comes down to is that people trust us to do, well by their problem, and that they trust us well enough to let us do what we consider right. They understand that we're giving them as much access as they like to how we do things. But I've kind of stopped. You mentioned, how do you sell this to clients? I should mention, right? I don't try to convince people that it's the greatest thing ever. If they're interested, then I'll explain, I'll spend all day long what I think is great about functional programming, but ultimately, we tend to have negotiations more in terms of what we can do for the clients. And some clients then, throughout a project, get interested a little bit in what we do, and maybe have us come in and teach a couple of classes. But of course, to again put that into perspective, of course, this all has a strong sort of survivor's bias, in the sense that, because it's like functional programming is right there on our homepage, maybe we don't even get to talk to other people, right? To clients that really are skeptical of using functional programming. And so I'm just saying it's not. So I can say, on one hand, it's not a big deal to sell functional programming. On the other hand, it might be, because there's lots of other clients out there. Might be lots of other clients out there that don't hire us solely for the reason that we're doing functional programming. So that's sort of the client side of things, right? So my feeling is that so I talk a lot at developer conferences. So I try to talk to a lot of people who are not in functional programming. And there things have certainly evolved over the last 10 or 15 years to the point where everybody has heard that functional programming exists. Most people have at least heard that it's a great idea, that it's a better idea than what it is that they're doing. And I talk to lots of people who go, well, I wish I could do that if my management let me do it. So we're definitely making progress. And we're also making significant progress. We're not just we don't just do software development, but we also teach a lot. We have, in particular, we teach a class on functional software architecture, which also contains an introduction to functional programming. And that's mildly popular, let's put it like that. Certainly much more popular than it was 5 years ago.
So when you say that you teach, this is part of the kind of consultancy you do? You guys go to the company and you teach those concepts to them?
It depends, right? And sometimes, so in the past, so there's a couple of scenarios that happen. So sometimes we do a software project and the client, but ultimately for a company that also develops software, right? So we would develop a product or some internal system for them, and they're interested in their own people also being able to keep developing it. Especially if budget-wise, it's difficult to maintain, just shipping us money for it. And then we might offer them a course on whatever technology or technique that was involved in creating that software system so that they are then able to maintain it after we leave or together with us maybe. And so that's one scenario. Then there's other scenarios that sometimes companies will come to us and say, well, our developers are interested in functional software architecture, and we see that you offer this class. Could you come into our company and teach this? And we do that also for some certain other subjects in software architecture. And then we also do open classes where you can sign up individually. And then I'll just have a mixture of people from different companies, or we will have a mixture of different people from different companies and teach them. So, yeah.
That's awesome.
All of that happens. Yeah.
What would you say is the hardest difficulty of someone coming out of an imperative program to learn functional programming concepts? Where do the developers get stumbled upon?
I don't think there's anything hard about it, right? It's, if you teach it right, I should mention, right? So teaching people how to program, not just as beginners, but into a new program paradigm is very sensitive to the didactics. I tend to talk about this for hours, so I kind of need to focus my thoughts here a little bit. So the important thing here is that if you want to teach successfully a wide variety of students, right? Your average object-oriented programmer that comes in, some high school graduate that comes into the intro class, right? If you want to do that, the only approach that I know, or the only family of approaches I know, does that systematically, in the sense that, of course, you would think you would do that systematically, but the purple book that I mentioned, for example, right, is a great book on computer science, but it's a poor book on teaching. And it's a poor book on teaching because it just presents wonderful examples and explains, how they work and why they work. But it doesn't really explain the techniques that the authors use to construct those examples, right? And so as a reader, you sometimes, maybe you kind of see it by osmosis. You look at the example and see, well, okay, now I can do and apply that. But a lot of students do not see that from examples. So you really have to be systematic in your didactic approach and really say, well, so for Matthias Felleisen's group and the PLT group pioneered this approach called Program by Design, or their book, and How to Design Programs. So where things are pedantically systematic. So you look at a problem statement, you structure it according to semi-systematic and systematic techniques. You derive pieces of your program from that, and then there's only very little creativity involved in sort of finishing the whole thing. And this is what enables people to program successfully on their own. If you're teaching beginners, you need to put everything in the service of enabling that, the systematic programming. And so apart from the didactics, you need two more ingredients. It turns out that it's beneficial to have programming languages that are geared towards exactly that. So, I mean, when we started out, as I mentioned, the Purple Book uses Scheme. Scheme is a great language, and you would think it's great for teaching because it's so small, right? And you only have to explain very few things. You only have to spend very little time explaining to beginners. But it's a terrible language for teaching beginners. Because it wasn't designed for that, right? It was designed for researchers, not for beginners. So you can evolve Scheme into a language that's suitable for beginners, but it changes right throughout that. So the system that we use, Racket, contains specific teaching languages for that purpose, and we also have a teaching programming environment, Dr. Racket, that we use for the introduction to functional programming, no matter if it's for beginning programmers and or experienced object-oriented programmers. And the beauty of it, once you do that, right, all the fundamentals of programming are accessible to just about everybody. Everybody who comes, I mean, who has the slightly more advanced high school diploma that you need in order to attend a university, or to the people who've already programmed successfully. So there's nothing inherently difficult. In the commercial space, what's more difficult is just that you have very little time. So we teach 4-day classes. They include a crash course in functional programming on the first day using the teaching languages. They include an introduction to Haskell. And then we talk about data modeling, combinator models, macro architecture, type classes, the type system, and so on. We do all of that in the space of 4 days. And it's just the sheer volume that's difficult, right? But other than that, I mean, the great thing is that all of this systematic programming also, I mean, we know how to do this with functional programming. I think as a larger community, we don't know how to do this with object-oriented programming, which is why a lot of object-oriented software systems out there are structured haphazardly rather than systematically.
And I think it's interesting for you to say that, because like there's a lot of books and blog posts and people trying to argue how much effort they're putting into doing good software architecture with object-oriented programming.
Yeah, it doesn't work.
Do you think OO is dead?
Well, that's a larger question. So yeah. So first of all, yes, it is dead. So in a very strange sense of the word, right? I mean, the sort of intuitive idea of object-oriented software is, right, the things in your problem domain become objects in your software, right? It's a very simple idea. It seems kind of evident now, but of course, at the time that object-oriented programming came up in the 70s, it was very different, right? People were using very sort of basic means to structure things. And then in the 90s, there was all this work on how do we structure those objects to match our domain. There was object-oriented analysis, there was object-oriented design, there were all these techniques. There was model-oriented architecture, there were all these techniques. They weren't always great, but they were at least adequate in many ways. I'll talk a little bit about what it was that was not adequate about them, but there was this rich discipline of doing that, of designing objects and classes in order to match the things in your domain. And that has disappeared from practical software development. So it's no longer being taught, it's no longer being learned, and it's no longer being applied. And that's kind of a strategy. That's kind of a tragedy. So if people say, object-oriented programming works, if they say today, object-oriented programming works great for software architecture, what they usually mean is something else. What they're usually not doing object-oriented programming, but they're doing something else. And a lot of the things that are relevant in modern software architecture are not directly related to object-oriented programming. So where I'm at, a lot of people practice something called domain-driven design. And domain-driven design is mostly, the way it's being applied at least, is mostly about sort of structuring sort of the large-scale structure of a software system and splitting it into parts so that you can then design the parts using very effective mechanisms that are sort of on the human side of software engineering, because you need that structure to match the team structure that you have. So So domain-driven design, highly recommend that you check it out. On the other hand, there's this other half in that in order to match the grand design that you came up with in domain-driven design, you need to, close the gap between that and the implementation. Domain-driven design contains something called tactical domain-driven design, which is a lot more vague than the strategic design. And and there, the fundamental idea is that you distinguish between things called value objects and entities, and a couple more things. So there's a sort of technical taxonomy of distinguishing between different kinds of things, right? Entities are things with state. Value objects are descriptive things. And that discipline is not very effective, I would argue, and it's not object-oriented programming, right? It's something else. It is tactical domain-driven design, and where it's unfortunately, what's really been lost in that shuffle and the transition from object-oriented analysis and object-oriented design to domain-driven design and tactical domain-driven design, insofar it's being even applied, is that as a software development community, we no longer know how to structure data. Your eyebrows go up, right? How is it possible, right? It wasn't computing called data processing, in the 80s, and so on. So, or maybe to put that on its head, and maybe to formulate it in more positive ways, right? So the way that I like to think about functional programming and functional software architecture is that it's really programming with data. Everything is data. In that, we would. So in this didactic approach that I mentioned, how to design program, the design recipes are fundamentally data-centered, right? The data, you design the data, and from the design of the data, you structure the program around it, right? This is classic. This is the way that I grew up, right? Is you design the data types, and then you design everything from there. This is no longer the case in domain-driven design. Now, in the systematic approach of how to design, in the systematic approach of how to design programs, you distinguish between two things, between what that calls mixed data and compound data, or you might say more formally sums and products, if we're leaning into the mathematical side of programming. Now, and of course, then you would say, well, then you get to the concept of maybe algebraic data types in strongly typed functional languages that combine those two things, where you would always have a sum of products. Again, why is that effective, right? You would think that's extremely effective structuring domains, right? Things in your domain can very often effectively structure through algebraic data types, even though the concept of algebraic data types was not designed with concrete domain modeling in mind, right? Because of because we're not modeling the domain, we're modeling the way that we think about our domain. Now, programming, so I mentioned products and sums, right? Products are, your thing has this attribute and this attribute and this attribute and this attribute, and sums are, it could be this or that or that or that, could have different structure. Now, not all programming languages have this concept of sum, right? So famously, SQL doesn't have it. Relational databases don't have sum types. And classic object-oriented programming also doesn't have that directly. You could emulate it with a class hierarchy, but it's kind of indirect. And right, it's not. It's kind of an encoding of that idea. The problem then is you run into sort of, Wittgenstein's dictum that the borders of your language are the borders of your world, and so it tends to. So a lot of software out there contains really poor data models because their authors tend to not think in terms of sums, and this tends to be neglected in sort of programming education and software architecture education outside of functional programming, surprisingly. So you would think, how can you get things done without that? But that is really not. So what people think of is I mentioned these things in domain-driven design, whatever your entities and your value objects, and then they maybe get to the point where what attributes do I need there? But that's a very basic question. And you cannot get from there to more advanced data models, specifically the combinator models that we use in functional programming, which you need sum types for combinator models. And you also need abstraction, which the software architecture community at large has gotten averse to. So this means that a lot of software, a surprising amount of software out there, just kind of pushes pieces of data around, but doesn't really have the rich structure that would make the software be great and make our lives better, right? Because if you just think, so I mentioned relational databases. There's also Excel, right, which is also has rectangular structure. If everything is rectangular and tabular, it's just boring. Not just boring, but you don't get the rich data models that would really make your software be the life enhancer and life improver that I think software needs to be, right? If you look at digital transformation projects, lots of them are, if you talk to their users, right? Users go, right, really, I've got to do this. I've got the paper thing, and then I've got the computer thing on top of that, and I've got to squeeze my idea of how the domain is structured into a tabular structure and maybe the comment field. And they don't see a digital computer system as a way to make their lives better, and that's a tragedy. And so this is where we need to go with functional programming and with types. We need to show people not just how to implement the technical side of their software system, but how to make their lives better, if that makes any sense. So, and I think the software architecture community at large, and the object-oriented community has dropped the ball on that a little bit, and they will really benefit. Once we manage to communicate better from these ideas about data modeling that we have in functional programming.
You do mention types and type systems now, and I think you're in a perfect position to give a good trade-off of having a strong type system such as Haskell and have no type system at all, such as Scheme. What are your views? Like, what types can bring to the table, and what is a trade-off in practice?
Types are fundamental for program design, right? And this how to design programs approach that I mentioned is fundamentally type-driven in the sense that
you say that because of the modeling of the data, for example,
yes,
as we were
the modeling
talking?
of the data. Mm-hmm. So you start by saying, this is how my data is structured, and you explicitly declare, here's a sum, and here's a product, and here's here's. So we have something called signatures in the teaching languages, and they kind of look like types where you say things like integer and natural numbers and strings and things like that. So as far as the declarative idea is concerned, I'm completely on board with types. So you should think about program design in terms of data type design. And then of course your programs follow that structure, and that those things go together. So, and things like type classes, for example, in Haskell are great to further document the properties of our data, and to document their algebraic structure, which I think what type classes are best for. So that's all great. And then there's the practicalities of static type checking, right? And there, the trade-offs are less clear, I would say. I'm a great fan of static type checking, but also a great fan of not having type checking. So maybe to give a very simple example, right? If you have algebraic data types in a statically typed language, that data type is closed. And that means, right? And so you have to put all the, your sum, you have to put all the cases in one place in your program. But in software architecture, you sometimes want to have, one piece of the sum in one place and another piece of the sum in another place. And you can do that, but it's awkward. So either by adding one level of indirection, by doing something like whatever types a la carte, which is great, but which took very smart people a long time to come up with. And so you kind of have to know it, right? It's not something that as an average programmer, you can be expected to come up with that. So there, your static types affect your software architecture in a negative way because it violates something called the open-close principle, where you would like to extend your software by adding to it and not changing it. But of course, adding cases to an algebraic data type means changing it. And we could argue about the expression problem and whatnot, but there you can see that there's a trade-off involved. Algebraic types are great. You get pattern matching, you get exhaustiveness checks, things like that. But there's a trade-off in that you get negative architectural properties, negative architectural value. That is, in many cases, offset by the value of the data model, but there's a trade-off involved. All in all, though, I mean, it's great. I think, though, maybe where I have a slightly unusual take on this was that, I mean, it used to be sort of the folklore thing that, well, dynamic types were great for doing something quick and dirty, right? You just don't worry about the types, right? Put it there, put it out there, and get it working quickly. And the static types are something that you need as your program gets larger. And I think that's exactly upside down. I remember, maybe I can quote somebody else. I remember there was ICFP 2007 something, not 7, 6, 4, in Snowbird, Utah. And I was sitting out at dinner with Olin Shivers and Benjamin Pierce. And Olin had just created the what's now known as the ICFP programming contest. And they were having this conversation. Now, of course, famously, Olin is a scheme person, and Benjamin Pierce is more of a statically typed, or a type systems person. Definitely a type systems person, right? And of course, if you're a typed person, right, it's a mystery to you how anyone would ever want to use any of those dynamically typed languages, right? And so it was a mystery to Benjamin. So Benjamin asked Olin and said, "Why do you do it, Olin? Why just why do you? Isn't that so painful?" And Olin gave the spiel on, yeah, well, because I can quickly put something together, blah, 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 something like that. And Benjamin said, "You're full of shit, Olin." So I remember that to this day, right? And what Olin, and he said, well, and you shouldn't, and Benjamin, now I'm paraphrasing. So he said that verbatim, but now I'm paraphrasing. And Benjamin said, well, Olin, you put together this ICFP programming contest, right, where people do something in 48 hours. And if you look at the programs that are written, the static types help those people put together the program very quickly, because when you're writing programs very quickly, you have a function with 7 arguments, right? And if you get them wrong dynamically typed, you've got to run the debugger to figure out what's gone wrong, especially if you do that under type pressure. Whereas you're statically typed, the compiler will tell you put that wrong thing there. So especially as you're quickly evolving something quick and dirty, the static types help. So at least one half, I mean, what Olin claimed to be the benefits of dynamic typing is definitely not true. All right. Give you another example I forget when that was, a couple of years ago. For a while we had that workshop on commercial users of functional programming. And there was Ryan Trinkle, who's, I think, big in the Haskell Foundation these days, also commercial user of functional programming. And he said, well, the static typing lets us write these horrible programs, right? It's great, right? And Phil Wadler was in the audience, and he was horrified. He was thinking, well, all my life I spent on type system, and now it's enabling horrible programs. What have I done? What is it, Ryan? And Ryan said, well, I can write this function with 37 arguments, right? And we shouldn't do that, but I can get the arguments, sorted out if I do that in Haskell, and I couldn't do that in dynamically typed languages. So there is, so maybe we'll leave it at that, at putting those two things together. I think static types are an unqualified win in the small. I think they're great, right? And the restrictions that you incur are not so relevant there. In the large, I mean, I gave you with that one example, we could talk more about things. It is not so clear. And sometimes in a dynamically typed language, you can do more modular constructions to enable software architecture. But where those trade-offs come down to kind of depends a little bit on your project and on the people involved. So that's my take, right? So great for small programs, static types, not so clear, jury's out on large programs. And I think the functional community would really benefit from the researchers in type system to think about more about those large programs, where a lot of type system design was motivated by very small things.
Interesting insight. I would have definitely guessed the other way around, where dynamically. It's, for the
It seems
small.
it seems intuitive, right? But I don't think it's true. Yeah.
Okay. Another thing that I think might like we were touching on this, but I'm not really sure where it fits in the conversation. But you also have a paper at Hope about the history of Emacs Lisp. Like, what's your involvement there? Like,
yeah. Well, so again, going back in time, that group of in that programming competition that I was involved in, right? And somebody there said, the best editor is Emacs, right? And I'd never heard of it. And then I think back in the day, right? This is the day of floppy disks and no internet, and people were, exchanging floppy disks at meets at what's now would be considered a meetup and things like that, right? And so, and this was in the late 80s. And so I got somebody passed on a floppy disk that had something called micro Emacs on it. And micro Emacs is not quite, if you know today what Emacs is, it's an editor that has a Lisp dialect built into it. Maybe for those people who sadly don't use Emacs. So I had this thing called micro Emacs, and it had this sort of scripting sort of language built into it that had like one character command, so you could input very cryptic little scripts to fiddle with your stuff. And I already thought that was great, but then somebody told me, no, Mike, this is not the real Emacs. The real Emacs has Lisp built into it. And I think, so this was, of course, the original Emacs developed in the mid 80s, that we now consider the real Emacs, developed in the mid 80s, latter half of the 80s, was developed for Unix systems. And the Unix systems were not, Linux did not exist, right? So Unix systems were not accessible to sort of the general public. I had a clunky PC at my desk, but then a C compiler came out that could actually compile 32-bit programs on DOS. Right, DOS was a 16-bit operating system, and that enabled getting a version of Emacs that would work, on the machines that I could use. I don't know when that was, maybe beginning of the 90s, sometime beginning of the 90s probably. And so since then, I've been a user of the real Emacs. And then this was still on a text-based, screen back in the day. And then fast forward, I was at the university, we were writing programs, we were writing papers in LaTeX. So of course, we were using text editors, we're using Emacs. And then again, it was Peter Thiemann, my office mate, who discovered, so we were running Emacs in the terminal, but we were running X windows. And you kind of painfully realize that there's an impedance mismatch there, and that you would really like to have a window-based Emacs. And then Peter pointed out to me that there was a version of Emacs called Lucid Emacs that had come out, which was nowadays we would say a fork of Emacs that was actually X Windows based, and that would give you a proper graphical environment and would have proper menus and would be usable with a mouse and things like that. And so downloaded that, fiddled with it. Then I think Linux came out, or Linux was getting popular, and I was running Linux on my own machine. And I ported Lucid Emacs to Linux, which did not have a port at the time. And this kind of led me to contributing to Lucid Emacs, which later became X Emacs, which still kind of exists a little bit to this day. So I've been, and since then I've been a contributor, or I was a contributor to Lucid Emacs and X Emacs. Well, again, there were people problems between the X Emacs and the GNU Emacs communities that are, I found lots of documentation of that on the net. So that was one thing. So I was a user of Emacs. I also hacked a little bit on the actual Emacs Lisp engine underneath. And then, but I was also a programming languages researcher, and then Hopple 4, I guess, came along or something. So Hopple is a conference that happens every couple of years on the history of programming languages. And what the program committee does, it solicits papers on programming languages that they think is interesting. And for some reason, the committee had decided that it would be nice to have something on Emacs Lisp. And so they looked at the cross-section of programming language researchers and prominent Emacs people. and sent them an email. There were like 6 or 7 people on that email. Nobody replied. And I kind of felt it should. So they asked. They said, "Well, it'd be great if somebody could write a paper on the history of Emacs Lisp." By rights, it should have been done by Richard Stallman, of course, who's also kind of at that intersection, but he didn't reply, and he had, I guess, other things to do. But I felt that paper should be written, and I'm kind of really poor at saying no in situations like that. And so I kind of sent an email around and said, well, if there's one other person who would work on that paper, then I'm in. And then gracefully, Stefan Monnier came forward and said, well, I'll write it with you. And then Stefan Monnier was the maintainer of GNU Emacs, so it was good to have people from both communities also working on that paper. And then, well, yeah, I don't know, 2 years later, that paper got published, I guess, right? We did a lot of historical research and even, I think, a couple of interviews even for that to figure out what that history was. But
that's really cool. I really love learning more about history of programming languages. Maybe I should do a kind of spin-off of the podcast just about history of programming languages, because I think it's amazing.
Yeah, and there it's fascinating. I mean, Emacs Lisp really gives you a different perspective on programming language evolution, because this now really is a programming language. Of course, it starts out as a Lisp, but then it immediately gets into the territory we have to fulfill requirements. We've got to make that, things that the language really has to make the editor work. And so you can connect those two things. And it's really interesting to see the back and forth between that. And then for the longest time, right, people were just busy fulfilling requirements. And then Stefan got into it. It was also a programming languages researcher who kind of swung the pendulum back a little bit and I mentioned earlier this dynamic scoping thing. So Emacs Lisp was a dynamically scoped Lisp, even though at the time it was known that it was probably a more generally better idea to have static scoping. But the way that sort of Emacs configuration happens benefits from dynamic scoping. So, but for the longest time, it was kind of the dream. And I'd also written a paper on that because it enables configuration, but it also hindered growth of the ecosystem of Emacs Lisp code because it's fundamentally unmodular. And so Stefan did what I couldn't do and transitioned Emacs Lisp now to a statically scoped language, or there's now 2 Emacs Lisps built into Emacs. One is dynamically scoped and the other one is statically scoped. And that, of course, is bringing a programming language idea sort of back into this very practical language, which is very nice, and it's playing out very nicely. And there's more of that happening right now. And so there's a conversation happening between the requirements of a concrete software system and the design of the language. And I think we should have more of that.
Yeah, absolutely. For sure. So it really blows my mind how I don't know, you've worked on many different kind of things, like very applied, but also very people's oriented. And then you also came up with a couple of conferences, such as BobKonf and FunArch. Like, what is in your mind? Like, what is the history of those conferences then? Like, because you're already doing so much, like, and then you're like, oh, you know what? I'm gonna come up with something else for me to do because I'm not busy enough.
So Bob came out of, so we were sitting down, I think 2011. Remember, I just joined this company called Active Group, and we just decided that we were going to change the business model and trying to do software projects using functional programming. And we were thinking, we were thinking about how, well, nobody knows about functional programming. How can we make it more popular? And so we met up with a company that we're friends with in Freiburg, these days called Meko, that makes a great system for managing hospitals. That's written in Haskell. And they'd also, so again, my office mate Peter Thiemann had moved to Freiburg, and so these were kind of our comrades in arms there with using Haskell and functional programming languages in production. So and they were also interested in sort of making that idea of functional programming more popular. And so we sat down for a meeting, and we came out of that meeting with 2 things. We said, well, we should have a blog. And so we created a blog on functional programming, which so still exists to this day. It was exclusively German language, but just 2 weeks ago, it started to transition to being bilingual. So if you're interested, so the latest post, hopefully this week, we'll get it out in English as well.
I took a look at it, and the translation works surprisingly well. Nowadays, translation, especially with LLMs, translation is really good. So
it is. So that was one idea, and the other one was, well, we should have a conference so we can talk to more people who are having the same sort of issue as we are having, and we could meet up and maybe then make functional programming more popular that way. But the idea was also with Bob, we thought, well, if we just put functional programming there, then we'll just going to be preaching to the choir, and all the people who already know functional programming will come there. So we're just going to have our little bubble. So we were thinking about how to get a wider, more diverse community together at Bob. And so we said, well, the common theme is going. So we decided on the theme of being what's best in programming. So that's so Bob originally was an acronym for best of breed. But then Stefan Wehr drew this really nice mascot, and now Bob is just a mascot. And so since so we just how hard can it be to do a conference? It turned out actually it's not very hard to do a conference. So we just decided to do it. Especially, I mean, I really benefit from a great team and active group. And when I mentioned that a lot of my former students work with me, and when you're running a large lecture, so in the heyday, we had 320 students at the University of Tübingen, and then a team of student tutors. So that's a significant sort of organizational challenge of getting, back then not everybody had computers. We had to get computer pools organized. We had to get homework submission organized and all of these things. And so I think we learned together on how to organize things to get whatever things that were together. And those same people, then I was lucky enough to then be able to hire at Active Group. And so we kind of winged it the first year. I think we're still winging it in many ways. We're just kind of thinking, well, what are we going to do this year? And that's how the first Bob came. I mean, if you look at the repository, I think it's called for the webpage, says Bob 2015. We weren't sure whether we were going to do it again, but we just did it again. And there's some kind of community of people that we just very much enjoy meeting every year, and new people that are coming in that we also enjoy meeting. And also we get people from sort of adjacent communities that are also doing cool things in software development. And we're also getting a few, so it's mostly a technical conference, but we always get a few people to talk about the human side of software development as well. And that I always have the feeling that's especially particularly appreciated by the participants. Because we tend to get people that understand, okay, it's a tip conference. We're also, so I need to talk to these people in a certain way. And they do that very successfully. So for us, it's kind of a day out for the company. I think hopefully lots of us just enjoy doing that. And now that we've done it a couple of times, it's no longer as stressful as it maybe was in the early days.
That's something I noticed between the difference between these more technical conferences versus academic conferences. I feel like in technical conferences, the energy is higher in the sense of people are taking a day off from their work, they're traveling and having a good time. Most of the times their company are paying for their stuff. And academic conferences I feel like it's a little more heavy in this sense, it's part of the job being there.
There's also there's also difference in culture, right? So, I mean, one thing that we really wanted to do with Bob, I mean, I was coming out of a culture of academic conferences previously to that, right? So I was not, I'd spoken at a few developer conferences, but I was not very many. So most of my experience was with academic conferences. And at academic conferences, I mean, given that in computer science, or at least in programming languages, the conferences are also the main publication venue. And so it's this serious business, right? So the conferences are what are journals and other communities. And so the workshops are what are conferences and other communities. It means there are no workshops. programming languages workshops do not exist, right? Even though they're called workshops, they're really conferences. And because of the high value of the publication there and the importance of the publication there, maybe just again through the nature of the people involved, when people give talks and then there's Q&A. Now, what does Q&A do? What is the job of the Q&A? Is it to find holes in the paper, or is it there to show some appreciation for the work that was being done? Right? In academic conferences, is mostly somebody's trying to find a hole in your paper. So probably been guilty of that as well. And so with Bob, we really said very explicitly, for this day today, you leave. We have like an little opening session and a closing session. So we really try to get people together and not just people kind of go to rooms with talks and self-organize otherwise. And so I usually tell people, well, for this one day, leave all that cynicism and negative energy at home. And if you see something cool, then, tell that person about it. And that seems to work out fine. In most cases anyway. So I think that is for me, that is the largest difference in energies, right? We try to support each other at those developer events. We try to shoot each other down at the academic events. And this is especially relevant. You mentioned all those other workshops, right? So every year there's ICFP, unfortunately happening right now. So I'm not there for the first time in many years. But ICFP has many satellite workshops. So there's the main conference. And then there's workshops on all kinds of things, on whatever type-directed programming, on higher-order programming and effects, on whatever high performance, OCaml, Haskell, this and that. And my earliest involvement was either the Scheme workshop or this thing called Commercial Users of Functional Programming, which used to be one of the satellite events. And I ended up being also chairing CFP one year and being on the steering committee. And that was very cute. You could also see that clash because we really wanted people to come in and tell us about their positive experience with functional programming. And that didn't quite go with the culture of ICFP at large. And then in 2000, I don't remember, 15, something in Boston, Paul Hudek and Colin Elliott founded the workshop on functional programming in art, FARM. So and I was also on the first program committee, and I ended up chairing that one as well. Same problem, right? In that really people are doing fun and cool stuff, right? And then somebody jumps out and says, you didn't define your monad right. And you kind of go over, it's a workshop, right? And anyway, with CFP, CFP was always telling people about, that cool thing that somebody did in the commercial space with functional programming, not so much on how they did it, but that they did it. And so we figured, one of the issues is that ICFP is mostly, or functional programming, mostly an academic community. So you want to get people there to this commercial users event. So you have some presenters that tell people how great it is, but the audience then is mostly the people at ICFP who already believe that functional programming is great. So we had this, I think it was Simon Peyton-Jones who had this idea. I said, well, wouldn't it be great if we also had tutorials that, with this idea that maybe people who don't know much about functional programming yet would come to ICFP, and then there would be a bunch of tutorials that would tell them, how to do it, and then there'd be CFP talks that tell them, what you could do with it. And so I ended up chairing the first iteration of that called Defund at the time. It's not just called ICFP tutorials, and it's mostly now, again, it's very difficult to sort of move ICFP, to shift the focus of ICFP somewhere else towards more practical usage. So that was kind of a slightly futile effort, but certainly Farm evolved into something that was great fun. Every year there's a concert, I think, which just happened this weekend, if I saw the social media postings on this right. And so we ended up now bringing this together. Sorry, I'm always taking long detours. In 2019, ICFP and also the satellite workshop, of course, then were in Berlin, which is also where Bob is. And but on the other hand, Bob is usually in February and March. And I couldn't make up my mind whether, I really thought we should really bring those two things together, right? In some sense. And but we did a survey and we couldn't decide between, are we just going to just go all in and just do Bob and co-locate it with ICFP, or just do the regular Bob and then do something special. And we ended up doing 2 Bobs in 2019, one called the Summer Bob, which was co-located with ICFP, slightly different format. And my team also ended up doing the farm concert. So, and so that is one of the great advantages of working with exactly my people, if you will, at Active Group, the people that are there. They're not my people, but maybe I'm their person, is that for some strange reason, and I think coming out of the experience of teaching the intro course and the logistics of that, is that we just love doing events. And so we love doing Bob. We very much enjoy doing Bob, and we very much enjoyed also organizing the farm concert. Brought another friend of ours in, who's in the art scene, in the music scene. And so that was that. So now Bob is just, for us, it's just the fun event every year where we meet other people, and we get lots of technical talks of stuff that is really out there and that is crazy and cool, and that I think broadens everybody's minds, including ours. And so by the way, it is on March 13th next year. The call is out. So if you think you might be in Berlin around that time, then please consider submitting something. So that's Bob. You asked about FunArch. So So one thing that happened is, again, in that long-term effort of popularizing functional programming in order to market our stuff better, one definite problem that we had was, well, we were teaching functional programming in a commercial setting, and we did that maybe twice a year. So it was not a great business. And so we were thinking of how could we find more customers for this, and we ended up joining an association that concerns itself with education and software architecture, called the ISAQB. And originally, the idea was very narrow in that we would just establish a curriculum on functional software architecture within their certification program and then just teach that. And that worked brilliantly. So we're now teaching, I think, about 6 fun hours a year now, the training on functional architecture. But it kind of had side effects in that joining this association actually meant dealing with the humans, and ISAQB contains a lot of people that have a lot of experience with large software system that is completely different from my own experience. And so I ended up establishing contact and even some friendships with some of the people there. I'm now also in the group that does the foundational training on software architecture, and we're, again, a very diverse and wonderful group of people that have very different opinions and experiences in software architecture. And talking with these people, I realized for the first time, which kind of has been a theme through a lot of what I've been doing in recent years, and I guess through this talk as well, that these people, that we have not, as a community, as functional programmers, we have not communicated what it is about functional programming that you should adopt, and why you should adopt it, and why it should be interesting to you. Particular, we have completely dropped the ball on explaining to people how to do large software systems using functional programming, and including me, right? We've been developing large software systems using functional programming, and we always felt that, well, it's obvious how you do this, right? Of course, you put together, things in this way, and you have all these wonderful ICFP papers that tell you bits and pieces and individual aspects of software architecture. But then I realized that these people have a much more comprehensive view of designing these systems, which we have not developed in the functional programming community. And we have not even communicated very fundamental little ideas, such as the idea of combinator models, right, to the community at large. So this does not exist outside of functional programming, and even though it could just as well be an idea in object-oriented programming. So there was this huge communication gap right? I felt, right? And these people would tell me how they're designing their software, and this has nothing, literally nothing to do with how we design software. These things, software architecture at large and functional programming and building functional programming systems have evolved completely independently, as far as anyone can tell, for the past, since forever. So I felt in order to be more established or to establish functional programming, we need to communicate better. We need to talk to these people, hopefully convince them that it's a good idea doing functional programming, but also tell them how to do it. And so this required, naturally, not just talking at these people. You're the lambda calculus, do it and you'll feel great, but also listening to what they have to say. And there's a lot of experience outside of functional programming and how to build software systems that we should incorporate. To give you one little example, lots of listeners here will probably know Haskell, right? A very trivial thing. So there's this, I mentioned domain-driven design, and the central element of domain-driven design is that you develop something called the ubiquitous language. A more appropriate word would be ubiquitous vocabulary. So you talk on the domain side of things, you talk to your domain experts, and you listen to how they use words, and what words they use and what they mean, right? And you develop a glossary, and you use that glossary at all stages throughout your software project. So not just in the documentation, but also in your source code and the names of your variables and so on. This means you spell words out, so you don't have one-letter variables for things that mean something. So, and if you look at Haskell code, Haskell people like one-letter variables, even in larger projects, right? So I always, in the FunArch curriculum, we sometimes look at xmonad, right? That window manager. There's a type in the middle, and that has like 8 type parameters, and they're all 1 or 2 letters. Right. And one of them is the type for the windows. It's called A. Right? Please call it window. So, this seems like it's a small idea, but it's actually a very consequential idea in software development if you realize how radical or how complete that idea is, right? And so we could learn that from that community, and there's lots of other things that we could learn. We could also learn. One thing is that really so one thing that always struck me as very strange is that the software architecture people, when they assess the quality of a software architecture, they look at the module dependency graph, and they always, at talks, they show these big balls of mud of dependency. I'm like, how does this even come about, right? Why is this an issue, right? And then I realized, and then after a while, I asked, and I said, well, maybe the way it works is that you're using a language called like Java, which essentially has a flat namespace. It looks hierarchical, but it really is flat. And your modern IDEs makes all of that namespace instantly accessible, right? You start typing, it says, well, over there in that far corner, light years away in your software system, there's a name. Just use it, and you go, and it's there, right? And so I was like, the Java people, right? It's their problem, right? And they have all these mechanisms to counteract those problems, but that problem is exactly the same in Haskell. Exactly the same in Haskell, right? And probably going to get worse now that the development environments are getting better at accessing all those things in those far corners of the system. So we have, especially in this space of strongly typed functional programming, we have standard ML, its module system, from which the OCaml module system has evolved. So it solves, on a technical problem, it solves all those problems. But we have not applied this. I guess the people at Jane Street are applying it within their systems, but we have not communicated to the world that, at least there's at least 1 or 2 programming languages. There's OCaml that you can use now. It has a powerful module system. It solves that problem, right? And therefore, you should use it. There's very little documentation on how to use that module system, how to use things like type classes, and so on. There's all these intro books, but there's very little sort of on the larger side. And so, again, taking a roundabout route. So I realized there's this huge communication gap, and I can try to bridge it by trying to introduce sort of functional elements into the conversation there. We're slowly evolving. Also, the foundational curriculum on software architecture includes some functional elements, and that's starting some conversations there. But I also really would like the functional programming community at large to think about those larger scale software systems and how what they do could benefit them. Especially because I knew that a lot of people, even though their papers are, have programs that are 3 lines long, that what they do has architectural impact, right? But very rarely do they examine that aspect of what they do in their papers. So, right, and I feel it's gotten much worse, right? I remember in the 90s when Haskell came out, so the one thing, Phil Wadler had this great paper on views, which are to abstract over the concrete structure of an algebraic data type, which is exactly about modularity, right? This is programming to requirements, but it's one of the very few examples. And if you look at an ICFP program these days, find the paper that actually shows you how to address a requirement using functional programming, and it's difficult. And so I wanted to encourage people to write that. And since encouraging in the academic community means to give publication credit, the thing that I knew how to do was how to do a satellite workshop for ICFP, of which, I've chaired the scheme workshop. I've been on countless committees of the various other workshops. I knew how to run one, how to create one. Then I got together with Graham Hutton, who also knew how to do this, and he gracefully accepted to help create FunArch with me. So that's a satellite workshop of ICFP now just gone into its 3rd iteration, where we try to get the functional people to write papers where they think about large-scale systems. And it's a fledgling workshop, I would say. So it's difficult to convince people to think about these things in the functional community. But if you're listening, and if you think, well, I've written this paper, 5 years ago, when I could reframe it maybe a little bit in architectural terms, even though it's not strictly super original material, but I could reframe that paper, then think of submitting it either to next year's FunArch, which hopefully we'll have. There's also a functional architecture category at the Journal of Functional Programming, which I'm heading, where you could also send it. So, but write stuff up so that us who are trying to popularize functional programming and point at papers or point at books would be even better, right? And say, well, here, dear manager, if you're concerned, or dear programmer, you want to learn about functional programming, dear manager, you're concerned that your programmers might learn about, there's books. Here's this material. There's websites, there's blogs.
Maybe what we are missing is having a gang of 4 of functional programming and having design patterns, similar kind of things, right? Like where you really have this philosophy of what does it mean.
Yes. And that's another example. So that's another example, of course. The patterns thing, right? The functional community has always looked down on patterns because, 19 of the 21, gang of 4 patterns are just libraries in functional programming. We don't need no stinking patterns. But of course, we have lots of patterns in functional programming that are just different, right? But nobody's written them up. So I'm going to mention that I'm working on that issue.
There you go.
On that very issue. Actually, I worked on that issue today. So hopefully it'll take time, but hopefully something will come out of that as well. So there's lots of corners there in that space where you would think, well, we've been doing functional programming for so long now. Isn't it time to just go and apply it? And we know how to apply it, right? But we haven't written it up. And that makes it inaccessible to large parts of the developer population. And
I think it's one of the frustrating parts of academia too, is because there's a lot that kind of goes unsaid. Oh, that's folklore, right? But no, it must be written somewhere, because the next generation, people like me, we have no clue. There's nowhere. There's no way for us to know.
I mean, my favorite example that I almost mention every talk I give is so one of the great examples of an applied ICFP paper was, I think, in ICFP 2000 on financial contracts, which by Simon Peyton-Jones and Jean-Marc Hébert, which resulted in a company that exists to this day. So it describes a combinator model for complex financial products, right? And on page 1, so it gives 3 examples. On page 1, it gives 3 examples, and then it says on page 1, well, of course, every red-blooded functional programmer should foam at the mouth now and yell, build a combinator library. So there was this assumption, even then, right, 25 years ago, there was this assumption, well, of course, every functional programmer knows combinator libraries. But then you can turn that on its head and say, well, maybe that's true, but how do people learn about combinator libraries? So, and of course, they can find lots of ICFP papers that describe individual combinator libraries, right? Including some that I've written. So my PhD thesis was a combinator library for stage lighting, if you will. So, but how did we do it? Right? How did we do it? Right? It's like that process is not documented, right? You can see a little bit of progress because there's 2 different revisions of that paper published, and you see the differences, and you see some evolution. But the methodology, we haven't written it up, right? So I should say that was true. That was true until very recently, that nobody bothered to write it up. Sandy McGuire gracefully has written it up in his book Algebra-Driven Design. That's the only example I know. But of course, that book, the title of that book, you kind of have to know that's what's in there, right? And in order to find it. But we didn't, as a community, we just didn't bother. Really, seriously, we didn't bother. We thought, well, people should come to us, right? And that hasn't happened. And it's not going to happen unless we go to them and talk and listen.
That's awesome. I love it. That definitely resonates a lot with my goal with this podcast to bring it, like this depths of academia. What I like to say, like the ivory tower of academia to be more accessible, hence for all, right? Okay, let's see here. What else we've got? One thing that comes to my mind is that before we started this conversation, I mentioned so for the listeners at home, we were sending back and forth some emails, and I sent him a couple of questions that I'm going to ask today. And he's like, "I'm surprised that you didn't ask anything about type systems. Like, what is going on, right?" And before the conversation started, I tell him, "Well, I kind of see types as functional programming and kind of like implementation, the implementation aspects or like the concrete aspects of type theory, kind of." And you disagreed, Mark. Like, so let's have that conversation now.
Yeah. Let's see, from what side can we attack this? So, I mentioned earlier that really I think the value proposition of functional programming is data, right? And data means stuff that happens at runtime, first of all, right? So that is very fundamental. So this idea that you have data and you would manipulate it with a program. And because this really, I think, is the key to sort of a successful digital transformation, and that you have, that you have models of your domain that really reflect and enhance your understanding of it, and that enrich your life through, this idea of that you've actually cleaned up your domain a little bit and organize it in a way that we can make it accessible as data. Now, of course, we can use types to describe the data, but so of course, as you're into type systems and type theory, you get into this idea, well, can we also program at the type level, right? You pull things back into the sort of the static realm. And that's all great, that's all wonderful, but you kind of get away from this idea of data sometimes. And sometimes I feel that it's just being driven by the need to, well, we can do it, therefore we should do it, right? So a good example would be maybe that as people in the strongly typed world, we're trying to replicate the benefits of scheme macros that I mentioned earlier, right? So scheme macros are the way they are, and they are powerful the way they are because they can operate on sort of unfinished syntax, right? And the unfinished syntax, of course, also means that in a strongly typed language, it wouldn't have types yet because it's not a complete piece of syntax. It might be something that you insert somewhere. So there's been all these attempts to bring the benefits of static typing, to bring the benefits of macros to statically typed languages, right? And specifically things like meta or camel. And so a lot of people spent a lot of effort on saying, well, but of course, the meta language that you use to program the macros so your macros also need to be strongly typed, right? And it's definitely a viable research avenue, but the point really is here, the thing is, I'm interested in the program that runs eventually, right? That will run facing the user. Now you think, And the way that I think about it is, well, what is the purpose of making your macro language, if you will, or your macro template system statically typed? I mean, the idea of the static types is there that you can write a macro and you can figure out whether that macro is going to apply successfully without actually running it, right? That's what type systems are. You do something, a phase in a previous phase at compile time to predict or to prevent something that happens at runtime. Now here there are two phases now in compilation, right? There's one that's the macro expansion, and then happens the actual compilation. And so the type system at the macro level, type checks your macro definitions so that you don't have to type check your macro application, which corresponds to that later phase. As I said, that's a worthwhile endeavor, but the thing is, when you, the programmer, are involved in program development, the phase of macro expansion and compilation happens at once, right? You can't really, it happens in quick succession and you don't really see the difference between the two of them. So if a problem happens there, your resulting product, the result of macro expansion gets type checked. Right? So your program that you run has been type checked, it's type correct, everything is fine. So what is the benefit of having your macro definition be checked? I don't understand, right? As far as from a requirement standpoint, right? And so you can try to pull things back statically, but it's not always clear that there's a benefit there. There probably is a benefit, and I'm probably oversimplifying things, but for the longest time, people were just saying, well, we've got to have, we're statically typed people, so we've got to do that at that level as well. But I think they would have been better served to bring the benefits of macros, which are not in the statically typed macro definition, but in the hygiene space, right? And in the staging space as well, to those languages. But instead, they chose to spend their time on the type system of the macro definitions. And I think that was and which is where we are in that the macro systems for statically typed languages tend not to be hygienic, right? Or that we're just now beginning to understand the benefits of properly staging things. So, I really, when I think about practical projects, I want to run them. And so for me, as I said, functional programming for me is about data. Outside of functional programming, we're not seeing so much data. This is the stuff that we run with. And so I think the types, the applied type theory, whatever you want to call it, is a means to an end, but it's not the central idea of functional programming. The central idea of functional programming is everything is data.
Mm-hmm. Mm-hmm. I see your point. I think the way that I look at it, in some sense, is also that, like when we're talking about not necessarily type systems, but like type theory. For me, this is a very, very, very personal view, maybe, but it's about describing the language behind, right? And what you're describing here about the macro system, it's really hard to describe what this is doing right, because it's the structure that you're dealing here, the types of these macros is very complex stuff, extremely recursively complex. And I don't know. I also see that as part of some type theory as well. Yeah.
No, that's great. But there's this larger. The one thing that I really dislike about sort of the culture of type systems is that I mentioned earlier that I really prefer my programs to be constructed systematically, right? And we know how to do this at the level of the data and the functions operating on the data. I would argue we do not know how to do this at the level of the types, right? And ask any sufficiently advanced, Haskell programmer if they've ever spent an afternoon. The program is written, right? And the activity is only about making the type checker happy, really. And the way that they go about it is we'll try this and we'll see if it goes through. Oh, that doesn't work. We'll try something else. And then we'll fiddle there. And that's not my idea of a systematic activity, right?
Right. Yes.
In the sense, So that's the idea. So I would like to, and that's something that I never see mentioned in the papers on type systems, and that we would go more in that direction, right? That something would, rather than having a sexy new feature in the type system, we would go in the direction of having the type system be more predictable in its behavior, and be more amenable to systematic techniques.
What do you think about Rust in that sense? Because the compiler gives you a lot of output and a lot of information of what's going on with your types.
I don't really have any experience with Rust, so I'm not.
Okay,
I don't think I'm qualified to say that here. And the reason I'm not getting into that, I think really fundamentally, the way and Rust is fundamentally an imperative language, even if it got, of course, I mean, you could argue it's a functional language because it's got Haskell's type system, or something like that.
And some pattern matching.
I think it's fundamentally an imperative language. It's great ideas. I think it's great in some very specialized domains, right? I have no sympathy for saying Rust should be used for everything. You should really use functional programming for everything. Also because, I mean, all the stuff that the borrow checker does, again, having no personal experience with that, that's great, but these are fundamentally technical things. And I really am interested in using the type system to say something about my domain rather than about the technicalities of how my program operates, right?
I think the guy Edwin Brady with Idris, he definitely has some stuff just to say about that. You know, like how he has this philosophy that the compiler, the type system, has a lot of information that it's withholding from you. And it's hard to get it right. Like, how much information should I give the programmer without, I don't know, maybe overwhelming or saying too many useless stuff.
But Idris and I guess ACTA, where that idea comes from, right, is in a way is very ergonomic in that it aids exactly that process, right? So in the sense that you write down your data types, you then start writing your function, right? And then you push a button and it will flesh out your function according to the data types, which is follows the same structure as the design recipes. It just automates part of it, and it's still human guided. So this idea is very consonant, I think, with how I think about software development and how it should go. And I think Idris really does make it at least a little bit more systematic in that way, because it gives you, not in the sense that the construction is inherently systematic, but that it kind of gives you feedback, not just in the sense of this should go here, but it says your specification is not complete yet, right? And therefore, the program that I can generate for you is kind of garbage, or kind of is not meaningful yet because you haven't provided enough specification yet. And so that can definitely be part of a systematic process, right? But and I don't think we've seen the end of that. And I hope we'll see more of that, even in the age of LLMs that tend to do something similar, but not quite the same and not as precisely as Idris and ACTA do.
I see a lot of future. I think it's kind of like in a turning point in the history of functional programming languages, in the sense that we're starting to see mainstream programming languages. Like every day, we're seeing more and more mainstream programming languages getting more and more functional programming features, such as pattern matching, algebraic data types, type classes, right? And I think having initiatives such as FunArch right now is really exciting, in the sense of like making these ideas more accessible and having functional programming. What it really makes shine, not necessarily just in functional programming. Maybe we're getting to an age where there's not going to be too much difference between imperative and functional anymore.
Well, I don't know. Hopefully, we're still going to have communicate, though, right? And
right.
So as you pointed out, right, Java now has pattern matching. It has records and sealed interfaces, which combine you can use to very directly encode something like algebraic data types. So now we can really succinctly in Java do data modeling, right? And the designers of Java sell this as, now you can do data-oriented programming. So that's wonderful. My experience is that Java programmers don't know how to use these features, right? And so we are the ones, so it's not just like happening by osmosis, right? If we don't go out there and explain it to people. So I have a good friend, Falk Zippach, also from that association I told you about, who's a Java MVP and who regularly gives talks on like the latest features in Java, right? And so Falk and I got together recently and did a talk on programming language history, and but also ended up in a workshop together on where I ended up talking about combinator models, and I kind of asked the audience, well, do you want me to? No, we can program this. What do you want me to program this in? And they, the audience said, well, we know Java. Do it in Java, right? And so I don't do Java often. So now the funky thing is that I can now program in Java in a similar way as I do functional programming, even though I have very little practice doing Java. And so this funny thing happened is that normally I was writing Java code, but the audience was going, this is how you do these things, right? And right? And they were, this is what this feature was intended for.
Right.
Nobody had told them.
Yes.
Right. And we're talking about people really people from the Java community who are up to really are into what's going on there. Right. And the Java designers and the Java community produces those new features. They tell them, here's this new feature, here's what it is. Right. And we happen to have that knowledge, if only in the form of folklore on how to use it, but we need to go out there and tell people.
This is the use case. This is why
right?
it shines. This is why it's great.
Yeah. And otherwise, they're not. I'm really pessimistic on that they're going to figure it out by themselves.
I see. I remember when I think Lambda functions came out in Java. I think it was Java 18 and all those streams and all of that. And I opened it up and try it out, and it's just so dirty. It's so dirty because they have to get around all of like type classes and some reflections about some stuff to get the Lambda inside, but then the type checking to match some old existing stuff. And I'm like, no wonder it took so long for Java to adopt this, because you have to do so many boilerplate to get it around, right? Like to do a little bit of.
The problem is, of course, the foundation, right? It's that it's difficult to get these things into a language that was not designed with that in mind, and to do it in such a way that will preserve the nature and backwards compatibility. And you've got to hand it to the Java people. They are extremely good at this, at evolving the language, at figuring out what order to put things in such a way that they take the community with them, right? Which is another thing that we tend to not be so great in the functional community.
Oh, we've been talking for a while, almost 2.5 hours in. I think we've covered pretty much everything that we intended. Is there any final thoughts, closing remarks that you have in mind that maybe it's in your heart to share, but you didn't have the opportunity?
No, I think I said everything, right? If we're in a type theory podcast, right, think not just about the type systems, but think about the people using them and what they're using it for. That would be my message here.
Great message. For sure. I love it. Well, thank you so much, Mike, for this wonderful conversation. I had an incredible time. You were a very charismatic person. You keep thinking, I'm going through all of these loops, but it really makes my life as a host so much easier, because you just keep going, and you're really entertaining and teaching us about all these historical aspects. So thank you so much for the time and sharing all of these ideas.
Yeah, thank you so much for having me.
So this episode is also part of my trip to Zurich. Don't get me wrong, it was recorded, I think, 2 weeks ago. But I didn't meet Mike at Zurich Hack, but I met some of his co-organizers of BobKonf over there. And Farhad, the organizer of Zurich Hack, put me in contact with her, and we have some conversations. And we thought that definitely BobKonf and Type Theory for All had some stuff in common. And she said I should talk a little bit with Mike to see what, if there's something we could contribute with one another. And then we have been in touch. And I proposed that once they had a date for the call of proposals and all the dates for BobKonf when that would be happening, we should record an episode. And that's what we just did. So as soon as they had dates, they sent me an email and we recorded this. It was really, really great pleasure talking with Mike. He has done so much, has so much energy, so much passion in him, right? I am surprised because, like being CEO, being part, he's part in academia, but also part in the industry, and he understands very well all of these things, and he's really passionate about teaching. And the most surprising part of all of this is that he's kind of also an actor. It was a very entertaining conversation to have. Hopefully, I cannot make promises, but I would love to attend BobKonf, but it's really hard for me to travel all my way to Europe. Mostly financially speaking, I think a flight to Europe. I'm in Brazil, so a flight to Europe should be around like $1,000, $1,200. And that's not the kind of money that I have to afford right now. However, the community I did a crowdfunding to attend Zurich, and the community was extremely, extremely helpful for that. So I might start doing some Twitch streaming towards the end of the year, towards the beginning of the year. And hopefully, maybe, who knows, I'll be able to raise some funds and get me to BobKonf. It would be really cool to make a live episode over there. I absolutely love making live episodes. I might do one next time I visit Purdue, which should be in a couple of weeks. So stay tuned for that. Our next conversation will be maybe that one. I might do something at Purdue for sure, but after that, I'm already scheduling with no one less than Andre Bauer. And I feel like I've been preparing myself for that conversation for the last 5 years, since the podcast began, basically, because Andre Bauer is a beast. So I'm really, really looking forward to that episode. What else I've got? Well, as I mentioned at the beginning, we have the mentorship program in full steam. If you're interested, check that out. And the most important thing that I just released is this Patreon thing. So I decided to pull the trigger and start doing paywalled content, basically. It's something that I kind of struggled with myself, kind of, because we already have no content being made in type theory and that kind of stuff. So why shouldn't I just go ahead and release on YouTube? And the reason why I'm not feeling I tried, but I started feeling like it's really hard for me because I wanna make content that I'm proud of and that I'm vulnerable with, that I really talk from a place deep within me. And it's really hard for me to have the same sincerity over a wider audience in the internet. I've been basically canceled before. I've lost my account on types.pl due to stupid memes. I don't think I still have the thick skin necessary to be producing content like that on the wild in the internet. So I decided to really gift the patrons for this. And I don't know, maybe we will also attract more people to become patrons. I don't know. But if it doesn't, it's fine. I'm not super worried about that. I feel deep in my heart the calling to be producing more of these things. I think I have a lot to share, a lot to contribute. I've been talking with a lot of people. I've been going to a lot of conferences, and I really want to share it with more people. So decided to start doing that on this very curated, very safe environment. So my goal is to build a more safe environment around academia. And I think people that have been following, they're really cool people. I really love the community that we're building at Type Theory for All. The Discord has been growing immensely. Very happy with the kind of people and the kind of connections that I've been making. So I'm really, really excited and looking forward to the kind of things that we'll be seeing going into the future. Did I forget anything? Well, if you have any thoughts, send me an email. We have contact@typetheoryforall.com, or I'm always quite available on Discord. Feel free. Sometimes I take DMs. I'm not going to promise that I'm able to answer all DMs, but as long as our community is small enough, why not, But things are starting to grow. So got to take the opportunity as it's still kind of small enough. There's definitely the good side of being small, exactly because, we're a small little community, small town. We know everyone knows one another and we can have a good time. Just us, But it's also nice to grow a little bit, be able to impact more people. I think that's it. I'm pretty happy. I think I'm in a really good place in my life, and just sharing it with you guys. I hope you guys are too. Make sure to rest. Make sure to go to the gym. Make sure to take care of yourself. I don't think life's just work. There's a lot more than that. Make sure you do things that you enjoy, okay? Have a good time. See you guys next time.